hold on to your space helmets. We might be closer than ever to answering humanity's biggest question. Are we alone in the universe? For over 3.5 years now, NASA's incredible Perseverance rover has been conducting what could be the most important detective work in human history. Since touching down in February 2021, this robotic explorer has been meticulously investigating Jezero crater, a massive ancient basin on Mars that scientists believe once held a sprawling lake billions of years ago. If life ever existed on the red planet, this location represents our best shot at finding the smoking gun. But here's where it gets controversial. The latest findings might just change everything we thought we knew about Mars. On Wednesday, September 10th, researchers unveiled a groundbreaking study that has sent shockwaves through the scientific community. The team revealed that Perseverance has discovered fascinating minerals along the western rim of Jezero crater, specifically within the clay-rich mudstone formations of an area dubbed Jezero Falls. Here's the kicker. These exact same minerals, when found on our home planet Earth, are almost always linked to organic matter, the building blocks of life itself. Now, before you start planning your welcome party for our Martian neighbors, let's pump the brakes for a moment. The researchers are being refreshingly honest about their findings, emphasizing that we're not quite ready to pop the champagne yet. They stress that extensive additional analysis is absolutely crucial to determine whether these minerals truly represent biosignatures, scientific evidence of past life, or whether they formed through completely non-biological processes. And this is the part most people miss. Regardless of their origin, these discoveries prove that remarkably complex chemical reactions once took place on Mars. Whether driven by living organisms or not, these processes add yet another fascinating chapter to the story of a planet that has captivated human imagination since we first gazed up at the night sky. Let's dive deeper into the specifics that have scientists buzzing with excitement. The samples that caught everyone's attention were extracted from what researchers call the Bright Angel Formation, located within the northern edge of Jezero Falls. Among all the specimens collected, one particular rock has become the star of the show. Meet Cheyava Falls. When Cheyava Falls first made its public debut, it immediately grabbed headlines across the globe, and for good reason. Scientists were practically giddy about this specimen's bizarre, spotted appearance that reminded them of poppy seeds scattered across leopard spots. These millimeter-sized circular features, each encircled by distinctive black rings, contain iron and phosphate, two substances that here on Earth frequently result from chemical processes driven by microscopic life forms. David Flannery, an astrobiologist working with the Perseverance science team at Queensland University of Technology in Australia, couldn't contain his excitement at the time. "These spots are a big surprise," he remarked. On Earth, these types of features in rocks are often associated with the fossilized record of microbes living in the subsurface. For those unfamiliar with astrobiology, this is essentially like finding ancient fingerprints that might belong to Martian microbes. Naturally, the scientific team knew they had to investigate further. On July 21st, 2024, Perseverance took things to the next level by actually drilling into Cheyava Falls to extract a core sample. This sample, officially designated as the rover's 25th collection and nicknamed Sapphire Canyon, has become one of the most anticipated specimens in the entire mission. Morgan Cable, a research scientist working with Perseverance, perfectly captured the mystery surrounding this sample. I would describe the Sapphire Canyon sample as mysterious. We see these signatures that tell us chemistry has happened, potentially involving organics. But what does that mean? Could life have been involved, or something that didn't involve life at all? That tantalizing question hung in the air for months, until now. The newly published study provides an incredibly detailed analysis of the entire Bright Angel Formation. And the results are nothing short of fascinating. The research team confirmed that this outcrop could indeed represent a legitimate lead in humanity's quest to discover life beyond our pale blue dot. Their findings revealed tiny nodules and microscopic specks that are enriched with iron phosphate and iron sulfide, minerals that appear intimately associated with organic carbon compounds. Here's where the science gets really interesting, even for beginners. The key to understanding these findings lies in something called redox reactions. Think of redox reactions as a chemical dance, where electrons, the tiny particles that orbit atoms, get passed back and forth between different substances. When this happens, one substance gets oxidized, loses electrons, while the other gets reduced, gains electrons. It's like a molecular game of hot potato, and the results can be spectacular. The study authors discovered evidence that organic carbon, the fundamental ingredient of life as we know it, appears to have participated in these redox reactions after the original sediments were deposited. This process created the iron phosphate and iron sulfide minerals that have captured everyone's attention, and it all happened under relatively low temperature conditions. But here's where it gets controversial. Could these reactions have been driven by ancient Martian microbes? Janice Bishop from the SETI Institute and Mario Parente from the University of Massachusetts, Amherst, authored a companion analysis that draws some eye-opening parallels. They point out that here on Earth, microorganisms routinely interact with minerals in ways that mirror what Perseverance observed on Mars. These Earth-based microbes have been documented converting sulfates, containing oxidized sulfur atoms, into sulfides, containing reduced sulfur atoms, in the frigid, oxygen-free lakes of Antarctica. The implications are staggering. There is no evidence of microbes on Mars today, the authors acknowledge. But if any had been present on ancient Mars, they too might have reduced sulfate minerals to form sulfides in such a lake at Jezero crater. In other words, the chemical signatures Perseverance detected could be the ancient calling cards of Martian life. The evidence keeps piling up. The research team also identified green-tinted specks within the muddy clay deposits that might contain a mineral called vivianite. This particular mineral acts like a chemical detective, potentially revealing specific details about the redox reactions that occurred on ancient Mars. Each piece of evidence adds another layer to what could be the most important scientific discovery in human history. But, and this is a big but, there's one massive elephant in the room that's frustrating scientists around the world. For any definitive confirmation of whether Perseverance's sample tubes contain genuine evidence of Martian life, those precious specimens need to make the 140 million mile journey back to Earth. Unfortunately, NASA's Mars Sample Return Program finds itself trapped in bureaucratic and financial limbo. Budget constraints, shifting political priorities since the most recent administration change, and the mind-boggling complexity of the mission have left this crucial program hanging in uncertainty. This situation is driving researchers to distraction because there's only so much analysis you can perform on microscopic rock samples when you're separated by the vast emptiness of interplanetary space. The sophisticated laboratories here on Earth could unlock secrets that remain hidden from even Perseverance's advanced instruments. As the study authors diplomatically put it, ultimately, the return of samples from Mars for study on Earth, including the Sapphire Canyon sample collected from the Bright Angel Formation, would provide the best opportunity to understand the processes that gave rise to the unique features described here. The companion analysis authors drive the point home even further. Laboratory analyses of samples returned from Mars could also cast light on the potential for prebiotic and even biological chemistry to occur on worlds beyond Earth. So here we stand at a crossroads in human history. We have tantalizing evidence that Mars might have once harbored life, sitting in sample tubes on a rover 140 million miles away, while the mission to bring those samples home remains frustratingly stalled. What do you think? Are we looking at the first real evidence of ancient Martian life? Or are we getting ahead of ourselves? Should funding for the Mars Sample Return Program be treated as an urgent priority? Or are there more pressing concerns here on Earth? And here's the big question that might spark some heated debate. If we do eventually prove that life existed on Mars, what does that mean for our understanding of life in the universe and our place in it? The answers to these questions could reshape everything we thought we knew about our cosmic neighborhood. The only question is whether we'll have the patience and determination to find out.